Good day, everyone. Welcome to the Fasken 2022 mining series. This is our 12th series now this year. I'm Michael Barassa. I'm with the Global Mining Group here at Fasken. Today's session is our fourth of 15 sessions. Yesterday we had 3 sessions, which went very, very well. There is a housekeeping slide, I think, that's up on the screen for all of you to look at, and with information about surveys and so forth. So please do have a look at that. And so with that, I'm going to turn it over to Barbara Miller, my colleague in the Toronto office, and she's going to introduce all of the panel today for the topic on nuclear energy. So welcome, Barbara, and the panel.
Thanks, Michael. I just want to first welcome all our friends from around the world. We're absolutely delighted that you're able to join us this morning. As Michael said, I'm Barbara Miller, and I'm a partner in the corporate department of Fasken's Toronto office. My practice includes M&A and corporate governance, but also regulatory matters in a broad range of areas, including broadcasting and telecom, cannabis, and nuclear energy. I have the great pleasure today of moderating our expert panel. As the world continues to address global warming and climate change, there's a desire to eliminate or decrease reliance on coal and oil and gas, and in their place to promote more forms of clean energy. We believe that nuclear energy can make an important contribution in achieving the global goal of carbon reduction. The aim of today's seminar is to demystify the use of nuclear energy and to discuss its benefits as well as the opportunities available to and the challenges faced by the industry. To do so, we'll begin with the mining of uranium at the beginning. We'll next examine the energy market as a whole, followed by a review of new technologies being deployed to, among other things, increase efficiency and production levels. And we'll then learn some of the details about the Canadian project being undertaken at Darlington. We expect to have some time at the end of the presentation to open up the floor to questions. So please feel free to send your comments through to the chat function, and we'll try to respond to as many of them as we possibly can. So turning now to the panelists, allow me to introduce them. Do a little wave or a head nod as I introduce you. First, Sean Quinn, Senior Vice President and Chief Legal Officer and Corporate Secretary of Cameco Corporation. Jeff Whitt, President, Framatome U.S. Government Solutions, LLC. John Ball, Executive Vice President, Advanced Nuclear GE Hitachi Nuclear Energy. And last but not least, Gregoris, Project Director, Darlington New Nuclear Project, Ontario Power Generation, fondly known as OPG. Full bios are in the invitation for your viewing. So to get right into this and dive in with our first question, I'd like to direct it to Sean. Starting at the beginning of the nuclear energy cycle, Sean, can you tell us a bit about uranium mining in general and Cameco's operations in particular?
Sure, pleased to do that, Barbara. Good morning, everyone. It's great to be with you here today. I am speaking to you today from our Cameco's head office in Saskatoon, and acknowledge that it is located on Treaty 6 territory and the homeland of the Métis. I make this acknowledgement to reaffirm our commitment and responsibility to building meaningful relationships with Indigenous communities. Something that we at Cameco have made a priority of over many decades, and I'll have a bit more to say about that towards the end of my comments this morning. The theme for today's session, the future of nuclear power from an environmental, economic, health, and safety standpoint, is certainly of consuming interest to Cameco and myself. As Barbara's already mentioned, the commercial nuclear power industry starts with and relies on uranium, a mineral with which Canada has a very rich endowment, and Cameco is obviously heavily involved with. So this morning, I'd like to take you through a bit of an overview as to how we see the future of nuclear shaping up, touching on the nuclear fuel cycle, Cameco's place in it, the uranium market itself, including some comments on recent market developments and the importance of security of supply, and hopefully setting the table for our other speakers who are coming after me and going to talk about the nuclear industry a bit upstream from the mining and milling aspects of it. I'm going to echo my CEO, Tim Gitzel, and say we are very optimistic about the future of our industry and the nuclear industry more generally, and believe that the industry is back on, if I can put it that way. As noted in our last quarterly Cameco conference call with investors, the benefits of nuclear energy have come into focus over recent years with a durability that we believe has not been previously seen. This durability is being driven by the net zero carbon targets being set by countries and companies around the world. And Nick, if I could ask you to please advance to the, I think the next slide, this is appropriate here. These net zero carbon targets reflect what we define as the triple challenge in front of us. First, to lift 1/3 of the global population out of energy poverty by expanding the availability of clean and reliable baseload electricity. Second, to replace the about 85% of current global electricity grids that run on carbon-emitting thermal power with a clean, reliable alternative. And third, to grow global power grids by switching industries to electricity, such as private and commercial transportation, home heating, and industrial heating, all of which are largely powered with carbon-emitting thermal energy today, which is certainly the case here in Saskatchewan. So there is increasing recognition around the world that nuclear power, with its clean emissions profile, reliable and secure baseload characteristics, and low levelized cost, has a key role to play in achieving electrification and decarbonization goals, all of which augurs well for Cameco. While climate concerns have been a main driver for this rejuvenation in the industry over the last, I'll say, 2 to 3 years, another driver that's come into even sharper focus given the recent tragic events in the Ukraine is the importance of security of energy supply. The maintenance of a stable, steady electricity source of supply is a key security concern for any nation, an imperative that will continue to drive countries to seek reliable energy sources like nuclear and to get them from reliable producers. Nick, could I ask you to advance to the next slide, please? I'm going to take a bit of a step back and now talk about uranium and the role it plays in generating nuclear power. Cameco is one of the largest global providers of the uranium needed to fuel the current fleet of nuclear reactors around the world. The core of our mining operations is here in northern Saskatchewan, but we also have mines in the United States currently on standby and a joint venture with Kazatomprom in Kazakhstan. We also have deposits, we own projects in Australia and other jurisdictions that aren't currently being developed but are available if and when the market is ready for them. We are a leading supplier of uranium refining, conversion, and fuel manufacturing services from our Ontario operations in Blind River and Port Hope. Nick, if you could please advance a slide, thank you. The fuel fabrication and reactor component aspects of our business are key elements for the CANDU reactor fleet here in Canada and help give Canada a great leg up in addressing the security of supply of electricity comments that I already made. Nick, could you advance to the next slide, please? Thank you. Before utilities around the world can use the uranium that we provide, there are a number of steps. The front end of the nuclear fuel cycle consists of uranium exploration and mining, milling, refining, and then conversion to UO2 for the CANDU fleet and UF6 for the light water fleet. The light water fleet then requires enrichment, and then there is pelletization and ultimately fuel fabrication. After uranium has spent about 3 years in a reactor to produce electricity, the used fuel may undergo further steps, including temporary storage, reprocessing, and potentially recycling before the ultimate waste product is ready for disposal. Collectively, these steps are known as the back end of the fuel cycle. Nick, could you please advance to the next slide? Thank you. As I mentioned earlier, while the demand outlook for nuclear energy is durable and very bright, the current uranium supply side story paints a different picture. Persistently low prices over the past decade, largely starting with the Fukushima tragedy, have led to planned supply curtailments of existing productive capacity, development risk due to lack of investment in new capacity, and the end of reserve life for some mines. These concerns have been amplified by unplanned supply disruptions over the last couple of years associated with the COVID-19 pandemic that's challenged all of us, and related global supply chain and inflationary challenges that have interrupted the flow of goods and services in the uranium market. Currently, worldwide annual demand for uranium is about 163 million pounds, but current production lags this by and is only about 123 million pounds. This is a situation that we find a great motivator for our primary business. In terms of how the uranium market operates, the hallmark of it is long-term contracts signed between utilities and dependable producers. Dependable producers. In the uranium business, there's no substitute for a full-blown, utility-driven, long-term contracting cycle. That's because the contracting cycle, motivated by security supply concerns, drives value capture for us. It's what helped Cameco survive the recent down cycle in the uranium business. Long-term contracts are a key part of our strategy and always will be. They benefit responsible producers by ensuring the viability of mining and milling operations, and at the same time give utilities the comfort that the uranium they need to fuel their long-lived assets. For example, I think the OPG Darlington site is now going to run until at least 2060. The utilities need to know that uranium they require to fuel those assets will be there when the time comes. The other aspect that's important, and of growing importance, are the stringent ESG requirements of the past number of years. Cameco, I think, is well suited to help with that. A brief example of the positive impact that nuclear can have on the ESG front. The uranium Cameco supplied in 2020 would fuel enough nuclear energy to prevent the release of about 421 million tons of CO2. That's equivalent of taking about 90 million gas-fueled cars off the road. So we think that there's a strong role for the nuclear industry, uranium mining to play in the ESG, in meeting ESG requirements, which are becoming increasingly stringent. From an area of less than 7 square kilometers in northern Saskatchewan, our operations have the licensed capacity to produce virtually all of the uranium used by U.S. nuclear utilities in each year, and those utilities meet about 20% of total U.S. electricity demand. Nick, could I get you to move the slides forward? Yes. And for Cameco, it's not just about mining uranium. On this slide, I just wanted to pause and show the measures of success that are important to us. I'm not going to go through them in detail other than to note the importance to us of community support by looking at the one where the graphic that talks about how much money has been invested in northern Saskatchewan businesses. Nick, actually, while I'm on that point, could you advance one more slide? I'd also, going back to my comments at the beginning, simply like to point out here the importance of our relationship with Indigenous communities and our successful efforts to ensure an appropriate mix of employees in our northern operations. And then if you could move on to one more slide, Nick. It's not just about mining uranium at Cameco. We've always had an interest in vertical integration. We're vertically integrated to an extent already across the front end of the nuclear fuel cycle with our refining, conversion, and fuel fabrication. And we're positioning ourselves to respond to the growing need for uranium and other fuel elements to generate safe, clean, reliable, and affordable electricity by looking at other opportunities that would give us a greater role in the full nuclear fuel cycle. In particular, I would point to our interest in global laser enrichment, where we're exploring enrichment, which is necessary for some of the new fuels that might be talked about a little bit for some of the advanced reactors, and also potentially to help produce this high assay, low enriched uranium that's also required for some of the advanced reactors. Also, we're participating in the development of small modular reactors and have entered a number of arrangements to advance their commercialization and deployment in Canada, around the world, including with GEH, who will be speaking just after, a bit later this morning. And we're interested in nuclear sustainability services overall in the back end of the fuel cycle. And our GLE, Global Laser Enrichment, would have a significant role to play in the cleanup of historic enrichment facilities in the United States if it comes to fruition. Nick, I think you could advance one more slide for me. So as I noted at the start of my remarks, we're optimistic about the growth in demand for uranium and the growth in demand for nuclear power across the fuel cycle. At the end of the day, people want and need electricity, and they increasingly want it to be clean electricity, and there the options are limited. Nuclear needs to play a big role going forward, and the future, we believe, is very bright. Thanks for your time and attention, and Barbara, that concludes my remarks.
Thank you so much, Sean, for the good background on the source mineral that's needed to drive this industry forward. I'd like now to turn to Jeff and ask you, Jeff, if you could give us a broad overview of the nuclear power market generally and where nuclear fits into the overall market, as well as telling us a little bit about Framatome.
Great, thank you, Barbara, and welcome. It's good to be here today. Thank you for allowing me to be a part of the discussion as Framatome. I have been in the nuclear industry since 1983, and I started working out in fuel fabrication at the time. I've witnessed quite a bit of advances in fuel technology and how we as an industry have improved the utilization of the uranium. And more recently been engaged with the small modular reactors and advanced reactors efforts. I have a son in high school who's 16, and he is in the process of considering where he wants to apply his talents in the future. And it's encouraging to me that this industry, this part of nuclear, now promises to give young people like him a very great future career for clean energy as part of what we think is important for us. Going to the next slide, let me introduce you to Framatome just a little bit. And for over 60 years, we've been involved in designing nuclear power plants, supplying nuclear steam systems, and designing and manufacturing components and fuel assemblies. We have very strong as an integrator for automation systems and servicing all types of nuclear reactors around the world. And this slide is just to give you just an overview of the diverse capabilities that Framatome has that we apply to the Canadian industry as well as the worldwide. Things like a very robust research and development arm, technical centers that are used to be able to do validation and put skills in place to be able to service the fleet. We have a global team of experts as well as an extensive manufacturing and services organization. So we're glad to be a part of supplying that in North America. On the next slide, we'll talk about Framatome in Canada. We've been involved in the Canadian industry for over 50 years. We have active engineering offices there for over 2 decades now. And our current work includes engineering, maintenance, refurbishment services, as well as our new joint venture, Isogen, that provides cancer-fighting medical isotopes. And we're also on the forefront of cybersecurity solutions, which is getting a lot more attention in the last few years. Now let me turn to the next slide and talk about the nuclear power market that Barbara asked about. Since we're supporting this, I asked my team to pull together some key points about nuclear power in Canada, and I won't read all of these, but I do want to highlight First of all, that Canadian uranium is a key source for both Canada and worldwide power generation. Nuclear power provides a very reliable alternative to fossil fuels in the country's efforts to reduce greenhouse gases and to meet those goals that Canada's net zero by 2050 objectives. Other nations, other regions, other states are adopting very similar goals. We've seen quite a bit of that in the last year to 2 years. And it's changing the narrative and it's showing the value that nuclear can bring in solving the clean energy to meet these goals. One of the shifts that we are seeing, and a very good one, I believe, is that nuclear power plants are good candidates to leverage production for other sources, like I mentioned, the isotope production, but also pilot programs are underway to produce hydrogen from nuclear assets. And we're in various discussions recognizing that the SMRs and advanced reactors can be a very effective source for process heat for industrial applications, which is a very tremendous amount of the carbon load in our economies. And to the right, you will see how nuclear fits into the overall electricity mix in Canada as an example. Go to the next slide. I would like to highlight that nuclear power brings some very good paying jobs in all sectors of the production cycle, those being, as Sean has mentioned, uranium mining, the conversion and enrichment, also in fuel manufacturing, but as well as components for nuclear power plants, manufacturing, constructing of those plants. Operating the plants is a tremendous resource and a tremendous need for those who are operating. We also have inspections and maintenance, and as I mentioned, the isotope production. All of those different things create very good paying jobs. And even to the point, and Sean mentioned a little bit about the back end of the cycle, even to the point of decommissioning and dismantling plants, there's also a need in the industry. And the key is that the industrial growth of nuclear provides very good opportunities and economic benefits to where nuclear is being deployed. On the next slide, I'd like to look at the Canadian base scenario and the energy mix in a little bit more detail. I know this slide looks a little busy, but let me hit some high points. Nuclear currently provides about 9% of Canada's total primary energy supply, compared to more than 70%, if you add those numbers up, provided by the combined fossil fuels. And then the graph on the bottom shows that with the planned retirement of some plants, nuclear power's portion of that generation mix would drop significantly starting in the mid-20s, and even with the refurbishment of others. So without the refurbishment programs, nuclear power would virtually disappear in the next decade. That is a very strong need for being able to do that. Fortunately, Canada is addressing this, as you'll hear more today, and that will result in ways to keep nuclear power in the mix and make it cheaper, more accessible. And I think with successful demonstrations of new nuclear, we'll see this percentage mix change in a very positive direction. And I'm looking forward to hear John's update on what they're doing as part of that there in Canada. On the next slide, I'd like to just talk to you just briefly about technologies. There are a number of organizations developing various technologies that are shown here. The mix is broad, but it gives us what I would say is nuclear energy technology and solutions portfolio for our future. And it will address the market needs and allow them to be implemented as each design matures and successfully demonstrated. And it's a unique time in that if you look at that list, you'll see the light water reactors, but we have high temperature gas, sodium, lead cooled, and there is such a tremendous mix of technologies and solutions that I think we have a very healthy future for us in being able to deploy nuclear as clean energy. And the Canadian government has established the SMR action plan. It's the roadmap and action plan, which many of these organizations that you see there on the right participating in. So let me finish my segment with this next slide and some takeaways. Those various technologies are evolving. They're adapting to the current and the future needs in terms of the economics, the environments that they need to operate in, operational flexibility. And they have much more passive safety features. And they leverage things like modular construction, adaptive to provide energy to meet the needs. For example, The picture on the right is from some of the work that we have done showing nuclear energy providing not only electricity, but powering desalination, providing industrial process heat and hydrogen production. And when I first came into the nuclear industry and realized that nuclear is a huge heat source, you begin to look at how it can actually apply as a very efficient way to be able to do these industrial processes, even beyond electricity generation. So with the advantages of these technologies, Canada will be able to achieve its climate goals, providing great employment opportunities and additional benefits such as the medical isotopes, hydrogen, process heat, and waste reduction. So thank you for letting me join you today, Barbara, and the panel, and I'll now hand that baton over to John.
Thanks, Jeff, very much. So, John, we're hoping with all that background that you could speak to the different uses for small modular reactors and in general, and GE's current focus in that regard.
Great. Well, thank you, Barbara. And certainly it's a pleasure to be part of this panel. Let me just first start out and define small modular reactors. Today's reactors around the world generally, on average, are about 1,000 megawatts electric net output. When we talk about small modular reactors, we're talking about reactors up to 300 megawatts electric output. There's an even smaller class that we consider micro reactors, which is generally under 20 megawatts electric. And I'll explain and I'll show you illustrate some of those different uses. But if you go to the next page, there is tremendous interest and energy around developing new nuclear, specifically these small modular reactors, advanced reactors that Jeff discussed previously. This is a page that is produced by Third Way, which is a think tank out of Washington, D.C. They're very interested in the energy transition and to ensure and help raise awareness for the need to decarbonize around the world. And they view nuclear as being an essential piece of the solution. And, in total, globally, there's over 100 different reactor designs that are being contemplated. And these are coming from very small startup companies, even universities, to larger companies like ourselves at GE. And the reason for this, I think Sean teed up very well at the beginning. There is a need for countries and companies around the world to decarbonize. There's been a number of very aggressive targets, whether it be 2035 in some regions to decarbonize the electricity sector. But in common, you see many countries and companies with a need to decarbonize by the year 2050. Agencies have modeled the future in terms of different power generation sources. Our corporate research center at GE has studied this in detail. And many agree that in order for the world to truly hit and achieve net zero targets, that nuclear has to play a very significant role. And specifically, we believe that SMRs are the future of nuclear. If you go to the next page, I thought I'd just illustrate some interesting use cases that many of the companies or the technologies that are being developed on the prior page, these are the type of applications that they envision in the future. And a lot of this is driven by the fact, as Jeff mentioned, there's new passive safety features that will enable nuclear reactors to be sited near population centers. So just a few applications. If you think about the really small reactors, the micro reactors that I described, there's a great need in remote communities. Today, they largely depend on diesel generation, and the transport of diesel can be very challenging depending on the time of the year and very expensive. And so with a small microreactor, you can place one of these reactors in a remote location and not have the need to refuel it for, in some designs, up to 20 years. So that can provide very reliable power without the need for refueling. Data centers, which are, in this new world, the need and the expansion of data centers is significant, and they depend on very reliable and clean energy. And so placing a nuclear reactor at a data center on its own microgrid, separated from the overall grid to ensure that you don't have disruptions, is a very important future use of nuclear. The ability to place a reactor in the center of a city to power a clean transit hub, or to be able to site and utilize a reactor as part of a factory operation to provide high temperature and process heat for those applications. So this is the future of nuclear. These are some illustrations that were also provided by Third Way that I mentioned on the prior page. If you go to the next page, a little bit about GE, and we've been part of the nuclear industry really from the dawn of the commercial industry being established. We actually got involved back in the late 1930s upon discovery of nuclear fission. We established our atomic energy vision in 1955, and we've had a number of firsts through the years, including the first licensed reactor in the US, the Vallecillos boiling water reactor, and also we're part of a consortium that brought the first reactor to Canada, the Nuclear Power Demonstration Unit, that helped serve as the basis for the CANDU fleet. And this was done in partnership with Ontario Hydro, now known as OPG. And then we had the very first Generation 3 reactor in Japan, built on time, on budget. But much of our history and the decades of experience that we've had, and really the entire nuclear industry for many years, was focused on deploying very large reactors. So I mentioned on average, typical reactors are 1,000 megawatts. Some of these, even larger, 1,200, 1,300. We have a design even at 1,500 megawatts electric. But if you follow what's been happening in the nuclear industry with these very large mega projects, there's been a number of these large reactors that have gone over budget, way past schedule. And so the market in general has been demanding a much more cost competitive solution for nuclear. The world needs nuclear to decarbonize, but it can't happen at any cost. Nuclear must be cost competitive. And that's why we have focused on SMRs, and really to drive the simplest possible nuclear solution that drives a very cost competitive solution. That led us to the development of our BWR X300, which I'll talk more about. And another first, last year, OPG selected us as the first grid scale SMR to be deployed. And we'll hear more about OPG from Carol. But if you go to the next page, we are very honored to have been selected by Ontario Power Generation. And, they are, and we'll hear more, and really the country of Canada, the goal is to be a first mover in SMRs. And it's a very consequential decision, because if you think about all the supply chain activities that's required to be a first mover in a new technology like this, and the potential growth globally for SMRs, Canada is very well positioned to be a global hub for SMR exports and future deployments. And just to illustrate the impact of that, after OPG made their decision, Synthos, which is a very large privately held chemical company located in Poland, signed a letter of intent with us to deploy at least 10 BWR X300 SMRs, including using the supply chain that it will be developed from BWXT in Canada. Following that announcement, TVA recently at their public board meeting announced that they are pursuing the BWR X300 at their Clinch River site. So A coalition is really building around deploying this technology, and we see a lot of collaboration in the future between these companies. You go to the next page. A little bit about the reactor itself. It really, the name kind of speaks for itself. So BWR, boiling water reactor. X stands for the 10th generation boiling water reactor. So we've been building on decades of prior design. So 90% of what we're deploying is proven technology that has existed in prior designs. But there's some very innovative features of this reactor that make it very cost competitive. So we've scaled it from a prior design. It's licensed. We're using a design to cost approach, but the key is around simplification and this new innovation. And what it's enabled us to do is, number one, make it a safer reactor. It's going to be the safest design ever deployed due to its simplicity. But we've been able to eliminate numerous systems that are no longer necessary due to the enhanced safety features. And what that's enabled is a reduction in the capital cost to deploy. And we're estimating about 50% reduction on a per megawatt basis compared to today's large reactors. This reactor is flexible in operation. If you think about the future world where there's going to be a lot of renewable generation, it's necessary due to the intermittency of renewables to have a design that can be flexible and ramp up and down when the power is needed. Today's large reactors don't have that flexibility. This one pairs very well, highly flexible, and can ramp up and down in unison with renewables. It's ideal not only for electricity generation, but also ideal for industrial applications like hydrogen in the future. We've started licensing in both the US and Canada with a target to be operational by 2028. So with that, I'll conclude my remarks, and Barbara, back to you. Thank you.
Thank you so much, John. So with all of that background, we're now going to have the great opportunity to hear about a live project. So Carol, can you tell us a bit about OPG's new design at Darlington and how that's going and being rolled out?
Sure, Barbara, thank you. Good morning, everyone. It's a pleasure to be here today talking about the future of nuclear. Just a little bit about myself. I've worked in the nuclear industry for over 30 years now, all with Ontario Power Generation. And I'm currently, as Barbara said, working on the Darlington new nuclear project. So this project is to design and build an on-grid SMR at the Darlington site in Clarington, Ontario. So that's just east of Toronto. And the lands you see in this slide is the Darlington new nuclear property. Next slide, please. So before I talk about nuclear and our project, I'll give you a little bit of information on OPG. We're a provincially owned corporation and one of the largest utilities in North America. Next slide. We have a diverse portfolio of generation assets. So we have hydroelectric, nuclear, biomass, gas, and solar. And we have a long history of nuclear power, starting back in the 1950s with the construction of the nuclear power demonstration reactor in Ralston, Ontario. So this has been mentioned a couple of times. And, you know, I grew up in a nuclear family. My father and my family came here in 1970 to work at NPD in Ralston, Ontario. And my father worked in the nuclear industry for pretty much his whole career. So after that demonstration reactor in Ralston, we quickly followed with a number of other projects, including Douglas Point in Bruce County, the Pickering reactors, the Bruce reactors, and finally the Darlington reactors that are on the same site as our current project. So these plants have been providing Ontario with safe, clean, and reliable power for over half a century. And as has been mentioned before, they provide great, highly skilled jobs for Canadians who both work in the industry and who support the industry. Next slide. So why, that's right. So why is OPG leading the build of a first of a kind grid scale SMR now? Well, OPG recognizes that we are in the midst of a climate crisis, and the way that we power our economy is changing. So in Canada, the government has set a number of goals around climate change, goals for a net zero electricity grid, goals for greenhouse gas emission reduction. And in addition, carbon pricing is expected to reach $170 per ton in the 2030s. So I'm sure all of you have noticed the gas prices. I myself have converted over to an electric car. So I don't really look up at the gas prices when I pass one of the gas stations. But my son recently bought a muscle car, a Ford Mustang, and I know he's having trouble pulling out his wallet when he needs to fill it up. So the cost of gas, is going to increase substantially. OPG has developed a climate change plan with goals that include being a net zero carbon company by 2040 and leading clean technologies and solutions to help achieve a net zero carbon economy by 2050. So it's worth noting that Ontario closed the last of our coal stations in 2014, which has led to a significant overall improvement in air quality. Our climate change action plan includes nuclear as a big part, but it also includes new and refurbished hydro generation, electrification projects like charging infrastructure for buses, ferries, and vehicles, as well as hydrogen development projects, solar projects, and storage development, and technologies for carbon capture and storage. Next slide. So now I'll get into our nuclear initiatives. Our plan to bring SMRs online within this decade is clearly focused on the need to quickly reduce carbon emissions in Ontario and across Canada. So OPG, as you've heard, is leading the deployment of the BWRX 300 technology at Darlington and will help others where we can to follow our lead. OPG is in a unique position to be able to deploy these new plants. We have proven operational excellence with our current plants, Pickering and Darlington. We have built project capability that is considered industry leading with respect to our Darlington Refurbishment program. And we have the only site in Canada licensed for a new nuclear project. So a lot of advantages to us going first. Other provinces are also expected to be retiring coal plants and seeking cleaner generation by the early 2030s. So there's a potential for many more reactors to be built as fossil comes offline and as electrification drives demand up. As we heard earlier, these smaller, more modular reactors have the advantage to be able to be deployed more quickly than a conventional larger nuclear facility and for less capital investment. The operating plant as well can be more efficient with advanced safety, simpler design, and digital innovation opportunities. So there's a lot of benefits to this project in addition to advancing climate change goals. Clearly, there will be benefits to the economy for employment and benefits to businesses. We already have a capable nuclear supply chain in Ontario and Canada, and this project will engage and build on that supply chain. By having the first of a kind here in Canada, it's more likely that others will reach out to us for proven solutions and proven suppliers. Next slide, please. I mentioned Darlington Refurbishment. This is a nuclear project to extend the life of the Darlington reactors for another 30 years. So to recap, these are CANDU design reactors based on natural uranium fuel. To date, we have successfully refurbished one of these 900 megawatt electrical units, with 2 others currently in refurbishment. All 4 units are projected to be back online and ready to go another 30 years by the end of 2026. This project alone is estimated to save about 297 million tons of carbon. This is the equivalent of removing about 2 million cars per year from Ontario's roads. And not to mention, this station generates 20% of Ontario's power. Next slide, please. I would be remiss if I didn't mention our other SMR project. So we are partnering with Ultra Safe Nuclear Corporation to develop a micro-modular reactor planned to be built at Chalk River. So this is an off-grid commercial demonstration project that has potential applications in heavy industry, in mining, and potentially remote communities. Next slide, please. On the topic of health, safety, and the environment. So health and safety is our overriding priority as an operator. That's not just something we say. Safety is part of our culture. We will focus on safety in the plant design, in the execution of the project, and how we operate the plant. We heard how these advanced reactors have simpler designs and more passive safety features than our traditional reactors. They will also design in security, radiological safety, conventional safety, and environmental protections. One of the unique aspects of nuclear reactors is that they are also able to produce medical isotopes for sterilization of equipment and for life-saving medical diagnostics. This is a unique benefit to nuclear over other generation methods. Next slide, please. Our relationship with Indigenous people and Indigenous communities with rights and interests in the lands we are operating on is very important in this discussion. By engaging with Indigenous communities, by listening to them, by learning and understanding the truth about our history, we will set the groundwork for building relationships and partnerships with those Indigenous communities. Our interactions have also given us a perspective on environmental stewardship that we wouldn't have had otherwise. They have helped us set a goal for eliminating the impact to the environment where we can, as opposed to a standard related to regulatory compliance that most of us are used to. We are listening and we are learning from them, and we will incorporate Indigenous knowledge where we can into this project. As part of our reconciliation action plan, the project can also provide economic empowerment to Indigenous people by way of hiring, by way of Indigenous business contracts and investment into our projects. And this is something that we are committed to. So in closing, I will say that in Ontario, we have shown over many decades that nuclear can be the backbone of a safe, reliable, clean electricity grid. And SMRs promise to be the next more accessible way to add nuclear energy to our grid systems. Back to you, Barbara. Thank you.
Thank you so much, Carol. So that brings us to the end of what I'll call the more formal presentations, and we're going to move in now to the Q&A session. And please feel free to post questions, and we'd be happy to try to entertain them. I'm going to actually put the first question from the audience generally out to all the panelists, and each person should feel free to jump in. So we've been asked whether we can discuss the safety aspects of nuclear facilities with respect to aggression, such as is happening in Ukraine at the moment. Now, do I have any takers for that question from the panel?
Yeah, I'll jump in to begin with. And I think,
John.
Carol alluded to the fact that these new reactors are being designed with security in mind as well. And one feature of the BWR X300 that I did not mention and is new and different from today's existing reactors is the reactor itself will be located underground in a circular shaft. So that adds significant safety and security features. I will say that there's from a security perspective, there's kind of a top secret clearance associated with safeguards, associated with the details behind, how we, further enhance the security of these systems. But they are absolutely being designed for those purposes, or
Thanks,
to prevent those situations. Thank you.
Thanks. Would anyone else like to jump in on this question?
I would just, and I can't speak to it from a technical perspective, and maybe I'll throw it back to John, but this is not the first time that the history of, this is not the first time that concerns about security of nuclear plants has been raised. That was a significant industry issue after 9/11 in New York City. And I think the industry went through a 5 to 10 year period of hardening sites, if I can put it that way, and enhancing security to deal with potential terrorist attacks. And maybe John or Jeff can speak a little bit in more detail to that, but I do recall that. It's not the first time the issue has been dealt with by the industry.
Yeah, this is Jeff. I'll add to that. If you've ever visited a nuclear power site, there are layers of defense built into that. I mean, John talked about the security protocols, but there are layers of defense not only in how the plants are designed, but also how they're secured. And so I believe that those safeguards, as mentioned, post Fukushima, which has made it even stronger, are very robust. And there is an active, I'm sure, management of those sites to be able to make sure that they're defending them. Defense in depth is basically the way to say it.
I'll just throw in to what other people. There are international organizations who are watching that situation very closely. And I don't have any firsthand knowledge, but from what I've read in the industry releases that have gone out, both WANO, the World Association of Nuclear Operators, and the IAEA are watching the situation very closely. I did read that they were asking for a safe zone around those plants. And the WANO Center in Moscow, there is a WANO Center in Moscow, so I'm sure they're very tuned in to the activities in the Ukraine.
Thanks, Carol. So we have another question from the audience, which has been a topic for a very long time in terms of concerns that people have about the industry. And the specific question is, what about the issue of nuclear waste? Is there new technology to deal with that? And whether there's some less concerns that the people should have over disposing of this nuclear waste? I'll open it up again to the full panel.
I'd be happy to start on this question. Let me first of all just state that today's existing waste is very manageable as well as safe. And so if you consider all of the nuclear waste that's been generated globally, you can actually place all of that in a football field or soccer field, whatever your preference, about 10 meters high. And it's very safely stored, typically on site in containers. Now, long term, there's the plan for deep geologic storage in a number of countries. But let me talk about directly the question and new technology, and the answer is yes. There's a new class of reactors, and Jeff highlighted many of those, that use coolants that enable the consumption of used fuel. So whereas today we treat used fuel as a waste form, it actually is an asset. And today's class of reactors just aren't capable to fully consume all of the actinides that end up getting generated through the nuclear fission. In the future, with new policy, and there's a lot of development still left to do and licensing that needs to take place, then we're probably out in the late 2030s, 2040s before you'll see this widespread application of consuming fuel in a reactor.
Thanks. Anyone else like to add to that?
I'll just tag on to that. As we did mention with the different technologies, I call it a portfolio of solutions, and some of the designs that are being put in place will actually do just that. They will take that fuel that we consider to be used fuel and then turn around and put it in an environment where it can actually be further used. So I liked what Rita Barnwell said when she was at DOE some years ago. we don't always see it as a waste issue. We see it as an asset issue, and how are we using that and being able to do it. So, and that's part of the shift in mindset that I think we're seeing, and that's what the new technologies are doing for us.
Thanks, Jeff.
So as an operator, we are committed to reducing radioactive waste as much as possible. So when we operate a plant, there's 3 different levels of waste: low, intermediate, and high. The high level waste is really the used fuel that comes out of the reactor. But for low and intermediate, we have a number of methods to reduce that waste, not bringing unnecessary things into the plant, making sure that we're checking it thoroughly, making sure that it is put in the right category of waste. We use compaction methods to reduce the amount of storage that's required. So waste is a key part of our business. And with respect to the high level waste, the fuel, we store that in special places on site, as John mentioned. So we have a special protected area. The waste is very, very secure. If you visit one of our used fuel dry storage areas, unless you knew where you were, you wouldn't know there was used fuel being stored there. You can walk around freely. There's not any level of radiation that you can detect walking around the facility. So it's stored very safely, very securely on site. And the plan is in Canada to have a deep geologic repository in the future. And the Nuclear Waste Management Organization in Canada is in charge of that project.
Thanks, Carol. The next question, I think we touched on broadly, but more specifically, the question is, do SMRs have any impact on economies of scale, usually considered a plus for NPP?
Yeah, I'll take a cut at that one first too. I think that it's a great question, and it's really what led us to developing the BWR X300. The industry went large due to the benefits that you get by increasing output and the economies of scale that come with that. So when you go small, you actually go the wrong direction. And so the key is, if you're going to shrink the reactor, you must find ways to simplify it and take away systems that are no longer required. And that's actually what we did. So we've got a reactor that's 1/5 the size of our largest reactor, but as I mentioned, 50% more cost effective on a per megawatt basis due to the simplification. So that's the key. If you just try to take a large reactor and go small, economically, it'll never work. It must be simplified.
Thanks, John. So turning to some other questions, thanks, John. I'm going to turn to Sean and just ask you, for the benefit of our audience, what is the estimated time from discovery to production of uranium? What's your cycle?
I think, thanks for the question, Barbara. The working estimate that you would get from Cameco on the timeline from taking a deposit that's been discovered into a functioning mine and mill would be 10 years. And that would cover the period of time required for a full scope of consultation with affected Indigenous communities. You need that support. Licensing, CNSC being the lead there, but you still have to deal with your provincial regulators too. Technical, I don't want to overlook that, particularly deposits in the Athabasca tend to be extremely high grade. Both McArthur River and Cigar Lake, I think the average grade at Cigar is 17-18% now, but you'll run into much higher grades as you're mining. They present technical challenges, both in terms of the grade and the geological location. Lots of issues regarding water, and there's been very unique technical solutions to that developed over the years. So there's a lot of just hard engineering work, mine engineering work to be done. So I think I would stick with that 10-year working estimate as being the timeline to go from having a deposit to having a functioning mine and mill.
Thank you. Well, it's a long cycle.
Yeah.
Carol, maybe you could, we've spoken a lot about, you know, the uranium and the projects, but looking to Canada, what does it take to actually license a nuclear reactor, and how long does that take?
So nuclear power is regulated federally in Canada by the Canadian Nuclear Safety Commission. And in order to build and operate a nuclear power plant, you require 3 different licenses. So the first license is the site preparation license. And as I stated in my remarks, the Darlington site has a site preparation license already. It was originally granted in 2012 when we were planning to build a much larger facility on the lands. And the facility was built off a federal, the license was built off a federal EA based on bounding parameters of the technologies we were looking at the time. So as we go forward licensing this new SMR, one of the criteria is that we are able to show that we're still within the bounds of that original EA, and so are still in the bounds of our current license. With the site preparation license, that first license, we're able to do a lot of the preparatory work on site. So, you know, things like clearing and grubbing, bringing in services and building office buildings, non-nuclear type of builds. The second license we need to obtain is a license to construct. So in the license to construct, the licensee really has to show the safety aspects of the facility, the design of the facility, and show that they're able to manage a nuclear construction project. So the preliminary safety analysis report is one of the key inputs to a license to construct application, and we're currently working on that for the Darlington project. We also have to show that we have the right management system and the right controls to be able to construct the facility with safety and quality in mind. And then the final license that we need to get to operate the facility is an operating license. So before we're actually finished construction, we will apply for an operating license, and this will be necessary to actually load fuel into the reactor. So a license to operate application, you really have to show the final safety case of the facility you're building, and you have to show all of the programs and the procedures, the training, the staffing, the organization that you are able to adequately operate a nuclear power plant. So those are the 3 different licenses required in Canada.
Thank you very much. I imagine that it would be similar in most jurisdictions in terms of the process.
It's definitely built off the same principles, done differently, different types of licenses, but definitely the same principles are involved.
Thank you. So Jeff, we've spoken a lot about the SMRs and heard the example for GE. What do you think are the market projections overall for SMRs globally?
Sure. Referring back to the SMR roadmap that Canada put out in 2018, at the time, those conservative estimates put for the value of SMRs in Canada at about $5.3 billion between 2025 and 2040. And then globally, that market at a conservative estimate of $150 billion, which is a very large export market. But I would say that since 2018 and the level of activity that we've seen in Europe and with demonstration programs, I would say that even those are conservative estimates now. And as we see the BWX 300 deployed more, I think we'll actually see this market to be much well over $150 billion globally.
Thanks, Jeff. So John, following on that, where do you view the largest markets globally for your SMR?
Yeah, generally it's going to be in markets that are highly dependent on coal generation today. And one of the largest is in Poland. They're one of the largest emitters of CO2 due to their reliance on coal generation. I mentioned the agreement with Synthos on the at least 10 units. They've done a very detailed study in Poland and have targeted up to 49 sites that are ideally suited for coal replacement from coal to SMR. So we believe that Poland is going to be a very substantial market for nuclear and SMRs in general. And this is where we see really significant interest.
Thank you. Sean, in looking at uranium deposits, where in the world would one look to, other than Canada, for uranium deposits, and how active are they?
Sure. Well, obviously, Canada has a very great geological endowment of uranium, largely centered in the Athabasca, but historically, there's obviously been uranium mining in Ontario. If you go south, the U.S. has a uranium endowment. There's been lots of historical uranium mining in the right economic circumstances. You can see that pick up again. In terms of active uranium mining jurisdictions, I would look to Australia. They are a uranium mining jurisdiction historically, and they have a significant geological endowment. Africa, in particular Namibia, has active uranium mines, but the continent of Africa as a whole has other potential sites. But Namibia would be the big jurisdiction right now. Kazakhstan currently produces about 40% of the world's uranium. They have large deposits amenable to solution mining. And they have, over the last 10 years, become, as I noted already, the largest producer of uranium in the world. Uzbekistan also has uranium deposits amenable to ISR generation. Many other jurisdictions produce uranium, but in smaller quantities, and you don't see them in the world market right now. But those would be the big jurisdictions in terms of uranium production and potential right now.
Thank you. Carol, I'd like to turn to you now and ask you, what happens to the fuel when it comes out of the reactor? Like, what's the process?
So it depends a little bit on which technology you're talking about. Some of the more advanced reactors have relatively, well, I'm going to call it funky fuel forms that are a little different than what we're used to. But I'll talk about what we're used to. So for our CANDU fleet, we have online fueling for our CANDU fleet. So we have actually fuel handling machines that are constantly refueling the reactor during operation. So when we refuel one of our reactors, usually we'll push about, in a CANDU unit, say at Darlington, we'll push about 16 bundles out of that reactor every day. And so those bundles are taken by the fueling machines, robotic systems, to irradiated fuel bays, where they're deposited in the irradiated fuel bays to sit for a period of about 7 to 10 years to decay before they're then put into dry cask storage. So when the bundles come out of the bay, they're put into these large casks that are shielded casks, and they're transported to that on-site waste management facility that I was describing earlier. So with respect to the BWRX 300, that's not an online fueled reactor. That's fueled during outages, but much the same handling of the fuel that comes out of the reactor. So it would be taken out of the reactor during an outage, put in used fuel pools, and remain there for a period of time until it has decayed enough to go into a dry cask storage as well, and then stored on site. And as mentioned earlier, the plan for long-term storage of irradiated fuel is a deep geologic repository in Canada, and we're working on that project now.
Excellent, thank you. So we have about 10 minutes left, and I wondered if I could ask each of our panelists to take a minute or two and just think about what you'd like folks to know about the industry. What takeaway should they come from this discussion and know that nuclear energy is safe, efficient, and what you'd like them to know going forward about the industry? I'm going to start with you, John.
Yeah, I would really go back to kind of where I started in terms of just the immense focus in deploying new technology to meet the global demand to decarbonize. And, without question, if the world is truly going to achieve net zero, nuclear, must be part of the solution. Darlington and the project is ideally positioned to really help pave the way. And this project is so imperative to demonstrate to the world that we can deliver on time, on budget, so that the rest of the world can follow. These reactors are being developed in a way that are economic, that are cost competitive, and have the very highest safety features as well. Thank you, Barbara.
Thanks, John. Thank you so much. Sean?
I'll start by going ditto to what John just said. That's kind of the easy way out, but no, I endorse everything John just said. I would just add to it the security of supply aspect and the importance of electrifying the 1/3 of the world that doesn't currently have the benefits of electricity. I think domestic energy supply writ large, but focusing on electricity, is an issue that is going to be increasingly important going forward. And I'll look, at Canada, and led by, I think, what OPG's done on the nuclear side. We're very well positioned to be self-sufficient in terms of electricity generation. I think that's, you can expand that to North America very easily. But I also think getting SMRs out there to deploy in the balance of the world that doesn't currently enjoy cheap, reliable baseload electricity is just fundamental to global prosperity. So maybe a bit of a soapbox speech, Barbara, but I think it's worth making.
No, I totally agree with you, Sean. And, promoting employment and security are critical to help the globe. And certainly a goal for every country is self-sufficiency. No doubt about that. Thank you so much. Jeff?
Sure, thanks, Barbara. I think my reminder today is that nuclear energy is clean for the environment. And if we sit down and look at the energy density that nuclear brings, it gives you a much better baseload solution for that clean energy. What I mean by baseload, when you have a nuclear reactor running, it runs irrespective of the sun shining or the wind blowing or whatever the case is. And so you might remember a few years ago when we had this terrible cold period, that cold snap in North America. It was the nuclear power plants that kept sustaining that baseload. And so it's very, very important to see the value that it brings. The second part, though, is this industry, the nuclear industry, has a tremendous safety culture, second to none. I mean, Carol talked about the licensing process that you have to go through just to be able to prepare to be able to build, but the whole building and the operating of the plant has a tremendous safety culture. And I think this industry has the capacity to deploy more clean energy through nuclear. And I think it will also, as I've been in it long enough to see that we'll close that fuel cycle. Some of those questions that we were talking about earlier, we refer to it as waste. I call it closing the fuel cycle. So, that's my takeaway. Clean energy, great safety culture, and the industry will innovate and continue to address the challenges that we have.
Thank you very much. Carol, to you.
So I will reiterate what has been said before. I mean, I don't think we can battle climate change without nuclear. It is really the only way to provide that reliable, clean generation. And I think also that current nuclear operators like Ontario Power Generation and some of the others, who have been operating for many decades, have that experience, have that, safety culture in their organization. I think that we need to help others move forward and be able to be a nuclear jurisdiction as well. OPG is leading in Canada, and we plan to partner with other utilities to help them get off the ground with nuclear energy. And I think that other utilities need to do the same in their jurisdictions. So that's what I'll say. Thank you.
Thank you so much, Carol. Well, we're coming to the end of our allotted time, so I want to take the opportunity to thank everyone who's joining us for participating with us today. And in particular, I want to thank very much our excellent speakers for your very informative presentations. So Sean, Jeff, John, and Carol, really thank you so much for giving us the time today and explaining the industry and its future. It was very helpful for everybody. I appreciate it. We appreciate it. So thank you again. I want to just conclude by saying that the next session will be on technological risks and cybersecurity in the mining industry, entitled On the Path to Strategic Risk Planning. This actually next session takes place this morning at 11:30, and you can sign up for this and any of our other upcoming webinars at the Fasken Institute section of fasken.com. So again, I want to thank everybody for joining us, and once again, our speakers, and look forward to having the opportunity to do so again in the future. Thanks so much.